What I want to show you today is what I believe to be the best value enterprise storage systems available in Australia today. What we have here is the QSAN XN8012R. We actually have 4 of them here, ready to go in the final stages of preparation before they go to their final destination. These are actually 12 bay, 12 3.5-inch bays with an additional 6 bays in the rear. I'll show you those in just a second. You can see here, take a disk out, very simple. Slides out simple as that. We can see this unit's got 10 terabytes, it's got 12 10 terabyte disks in, so 120 terabytes storage in there. I have one, this lower one is actually powered up, so I'll be going through the configuration of that very shortly. We'll take a look around the back of this device. As I mentioned, there are an additional 6 slots at the back of these units. The first 4 are 2.5-inch SATA slots, so they take 2.5-inch SATA disks. The last 2, you'll notice, are actually NVMe disks, so you can get the 2.5-inch NVMe disk and slide them in there as well for extremely high performance. As you'd expect from an enterprise system, we have dual power supplies. We have 10 gigabit Ethernet. We have quad gigabit Ethernet. We have 4 USB 3 as well, and a HDMI socket if you need to attach your display. So what I'm going to do, I'm going to go through the configuration of all these units, show you how simple it is to get it up and running. I'm going to configure this QSAN storage device suitable for use as an backup repository device for Arcserve UDP, but you could use a similar configuration for other backup products such as Veeam or Acronis or anything else you can think of, really. I've spun up the QSAN. It's on the network, so first thing I need to do is find it. And there it is. It's been detected. It's using a DHCP address, and I'm just going to connect to it. And we'll go to an initial wizard. You can see that all of the 3.5-inch bays at the front are populated. And if I look at the back, I can see that 2 of the SATA SSD slots are also populated. We've got 2 more available SATA SSD, and we've got 2 NVMe slots available as well. Just to do the basic configuration, I'm just going to, on the front page, just set the time zone. This is going to a organization that is based in New South Wales. I'm going to leave DHCP until I'm informed of an IP address to set, or we can set it on site. Now, I have the option to create a pool type based on just generic storage or media streaming or database storage. I'm going to use the generic. Like I said earlier, I'm going to use this storage primarily to store backups. In fact, this will be used for a data store for Arcserve UDP. Now, Arcserve UDP has a fantastic deduplication engine in it that does require some SSD, which is why I do have some SSD drives down here. And the RAID configuration we're going to go for is going to be RAID 6. You can see here I've got options of RAID 0, 1, 5, 6, 10, Z3, which is I think an equivalent of RAID 6, RAID 50, and RAID 60. So um, all of those options are available, but for this particular use case, I'm going to stick with RAID 6, which means we can afford to have, or we can survive. The volume can survive with 2 disks, up to 2 disks failing. We have an option of enabling auto tiering, which means that if you were to use the storage as a file server, you could offer automatically allocation of high I/O operations being stored on faster disks, such as the NVMe slots that we looked at earlier, or SSD, or lower speed, lower I/O could be stored on the SATA disks. Again, I'm using this for backup, so we're basically going for SATA for the main storage, and the SSDs will be used to store the deduplication hash on the device. We have an option to enable encryption on the storage as well, which I'm not going to enable now. You can see here I have 12 what are 10 terabyte disks. So when you're working out your storage, I always take 10% away to work out the estimate of the size of the storage. I wouldn't want this to be kept as a spare. So I'm just going to deselect one of these disks. Okay, the last disk there is going to become a hot spare. And the rest of them will be configured into RAID 6. I'll choose my RAID 6 there. There you go. Interesting when you see when I deselected that extra disk, I did lose some options of my RAID configuration because I've now got an odd number of disks selected. RAID 6 will do me. Also going to remove these 2 SSDs from the RAID. They're not going to be in there. And again, choose my RAID 6. Okay, and choose next. You can see my estimated size of my RAID 6 is going to be basically 83 terabytes. And there are all the disks. I'm going to apply that. Okay, the configuration has been saved, and I can now log in using the default credentials and take a look. When we first log in, we're presented with the QSM, which is the QSAN Storage Manager wizard. It suggests that we create a volume, which again, if we were using this to present a file share to the network, we'd want to create a volume of a certain size, maybe a folder name, and share that, which in this case, I don't want to do that because I'm going to dedicate this as a backup drive. It's actually going to be attached via iSCSI to a Windows server. Just a few other options we have in here. It mentions that we do have option of 10 gig fiber or 16 gig fiber. QSAN do have 25 gig fiber available, but I think that's for their SAN systems. There is a backup product included with QSAN, so you do actually get a license that covers 100 desktops using the X-replicator technology, which is a OEM of Acronis. Okay, you get the option to create a QSAN ID with QSAN, which I'm not going to do. Again, I'm just going to continue down the process of configuring my storage for my backup. You can see there is my pool that I created earlier, and I'm going to give it a dedicated spare disk. I'm not creating multiple storage arrays, so I don't need a global spare disk. I'm just going to use a dedicated spare disk, which is slot 12. Okay, there's my spare disk. So there's my RAID. You can see it's, there you go, 75 terabytes of available storage with a dedicated spare. So effectively, we could lose 2 disks from the RAID 6, and we'd still be operational. But while those 2 disks has failed, the dedicated spare would kick in. So effectively, we could survive with 3 disks failing in this pool without loss of data. What I also want to do, though, notice I've got my 2 SSDs here, which I need to create a new pool for these, so I'm just going to use this simple wizard to create that. And again, I'm going to choose generic. I'm not going to use any tiering, and I'm just going to call this SSD hash. That's basically what it's going to be used for, is the hash drive. I'm going to choose both of these, and then I choose my RAID level. It's going to be a RAID 1. Okay. I don't have a spare for this, but I think that's okay. Okay, so there's my SSD that will be used for the hash, and I've got my data volume, which we use for the bulk of the storage. So I'm going to use this for using iSCSI. So if I go to my, so it's in, as you can hear, block storage, I'm going to create iSCSI volumes with the storage that I'll be able to attach to using a Windows server or Linux server. Okay. Now, before I configure iSCSI, I'm going to want to create a user account with which to authenticate against the iSCSI using CHAP authentication. So I'm just going to go to users here and just create a local user. And I think I'll just call it UDP. I need to give it a complex password. So I think that will work. Needs to be over 12 characters and less than 16 characters. So I'm just going to create that account. Okay, there it is. Now I can go back to my block storage configuration, and I can then select create. Now I have an option to create a target and map a LUN in just in one step, which is what I will do. But also, if I already had a target, I could create just a target if I wanted to attach additional existing LUNs, or I could create LUNs to attach to another target. For the first one, I'm going to create a target and map a LUN. And this is going to be my large UDP data store. So I'm just going to call it, target name is going to be QSAN UDP data. And I'm going to choose to enable CHAP. And I'll click on the users here, and you can see the account I created earlier. So I'm going to be able to specify that user account when I authenticate a server to attach to this storage. My LUN name, I'm going to call it, again, QSAN-UDP-data. It is going to be on my large pool, my large disk pool. And I'll actually type in the value I want it to be, make it 73 terabytes. And my compression, I'm just going to leave on normal compression. And confirm those settings, and that disk will be the iSCSI target, and the LUN will be created. Now for my second LUN, which is going to be on the SSD used for the Arcserve UDP deduplication hash, again, I can go through the create wizard, and I could create a separate target and a LUN, but because I'm using the same application, UDP, for both LUNs, I'm just going to create a second LUN and attach it to the same target. So name is going to be, again, QSAN-UDP-hash. I'm going to choose my pool that is using the SSDs, and I'm going to make it 800 gigs in capacity, which is basically the full disk. I'll leave a little bit left over. Enable compression, normal compression again, and click next. LUN's been created successfully. Now you can see the UDP hash LUN hasn't been mapped to the iSCSI target, so I'm just going to use this LUN mapping option to map the disk LUN to the iSCSI target. Okay, so we've got our iSCSI target using the CHAP authentication, and we have two LUNs attached to it. We've got one that is large, 73 terabytes on SATA disk, one that is small on a mirrored SSD. The last step to show you is actually connecting the iSCSI volumes to the Arcserve recovery point server. So I'm going to use the iSCSI initiator, and I'm just simply going to type in the IP address of the QSAN. Click on Quick Connect. It's going to say unable to log into the target. That's okay. I need to now specify the credentials I want to use, which, if you remember, the username was UDP and the password, if I can remember it. Okay, we're now connected. If we now look at disk management, so you can see I've got the large disk here. I'm just going to mark those online, initialize them both. Simple volume, drive letters. I think I'll just do P and Q. I think I'll do Q. I'm just going to call it QSAN data, and this second one is going to be for the hash. I'm actually connected to the QSAN via gigabit network rather than 10 gig, so I wouldn't normally recommend doing it under anything less than a 10 gig network if you're going to store the dedupe hash on the external storage. You do, of course, have the option of using the server or appliance's hash with the external mass storage. Okay, so I've now got my two new partitions. I guess the last thing to do is actually to launch the UDP console. Go to my recovery point server, which is this particular UDP appliance. Select add a data store, and again I'm just going to call it QSAN data store. My data folder is going to be on the P drive, and I'll just type it in actually as QSAN data store common. Enabling deduplication. I'm going to change my hash is on SSD, even though technically it's going through a gigabit network in this particular case, but I'm going to just create it like this anyway. Normally I would be using a 10 gig network, and I'm just going to change these paths. Data index and a hash I'm going to store on the Q drive hash, and I'll leave the remaining things. I will enable encryption and type in an encryption password. Okay, and save. Okay, we can see that QSAN data store now starting, and we can see 73 terabytes available storage. Hope you found that demonstration of value. Thank you.